Okay, so remember tomorrow you guys have a quiz on everything we've learned so far, including what we're looking at today. Yesterday we saw that you can graph lines using a table of values. Today we're going to look at a different way in which we can graph lines, known as the slope-intercept of a line. So we'll start by looking at this video. Listen up. Just hang on a second. Pardon? Nope.
So there's an infinite number of ways to represent a given linear equation, but what I want to focus on in this video is this representation in particular. To get the point, it's going to look something where I get it to, and I'm not going to do it right now, but this is another way of writing that same thing. Y minus 5 is equal to x minus 1. You could actually simplify this, and you could get either this equation here or that equation up on top. These are all equivalent. You can get from one to the other with logical algebraic operations. So there's an infinite number of ways to represent a given linear equation. But what I want to focus on in this video is this representation in particular, because this one is a very useful representation of a linear equation. And we'll see in future videos, this one and this one can also be useful depending on what you are looking for. But we're going to focus on this one. And this one right over here, it's often called slope-intercept form. Slope-intercept form. And hopefully in a few minutes, it will be obvious why it is called slope-intercept form. And before I explain that to you, let's just try to graph this thing. I'm going to try to graph it. I'm just going to plot some points here. So x, comma y. I'm going to pick some x values where it's easy to calculate the y values. So maybe the easiest is if x is equal to 0. If x is equal to 0, then 2 times 0 is 0. That term goes away, and you're only left with this term right over here. Y is equal to 3. Y is equal to 3. And so if we were to plot this, actually let me start plotting it. So that is my y-axis. Let me do the x-axis. So that can be my x. That's not as straight as I would like it. So that looks pretty good. All right, that is my x-axis. Let me mark off some hash marks here. So this is x equals 1, x equals 2, x equals 3. This is y equals. Let me do this. Y equals 1, y equals 2, y equals 3, and obviously I can keep going. This would be y is equal to negative 1. This would be x is equal to negative 1, negative 2, negative 3, so on and so forth. So this point right over here, 0, comma 3, this is x is 0, y is 3. Well, the point that represents when x is equal to 0 and y equals 3, This is we're right on the y-axis. If they have a line going through it and this line contains this point, this is going to be the y-intercept. So one way to think about it, the reason why this is called slope-intercept form, is it's very easy to calculate the y-intercept. The y-intercept here is going to happen when it's written in this form. It's going to happen when x is equal to 0 and y is equal to 3. It's going to be this point right over here. So it's very easy to figure out the intercept, the y-intercept, from this form. Now you might be saying, oh, well,
Okay, I had it working so that this would play through this yesterday, and now it's not working. I know it's kind of hard to hear back there, so I'm just going to stop this and go into the lesson. So the slope-intercept form of a line is when you get y by itself. It's known as the y equals mx plus b form. So remember we saw yesterday that when you have an equation, you can look at it and know that it's going to give you a line as long as there's no exponents anywhere. If there's no power on the y, no power on the x, that means they're both technically power 1, and a first degree equation will give you a line. It's linear. So yesterday we saw that one way to graph that line was to do a table of values. Find points that satisfy the equation, then we can say those points lie on the line, put them on a graph, draw your line. Now we're going to see there's a different way that you can graph lines, and that's putting the equation in slope-intercept form, which is known as the y equals mx plus b form. Basically, you've got y by itself on one side. In most cases, you're going to have two things on the other side. One term that has the x, and one term that is a constant that doesn't have an x. Well, as the video said, that term that is the constant that doesn't have the x tells you the y-intercept of the line. The y-intercept is where the graph crosses the y-axis. So now we have a point to start with, the y-intercept. So again, when an equation has no powers, that means it's a first degree equation, that means it's a linear equation. One way to graph a linear equation is by putting the equation in slope-intercept form. Get the variable y by itself. And when you do that, y is by itself on one side. On the other side, normally you'll have two different terms. One term that has the x, one term that doesn't have an x. It's a constant. It's a number. It'll never change. The first term will change depending on what you put in for x. Every time you put a different number in for x, you're going to get a different value for that first term. But the second term, the term that doesn't have the x, will never change. It'll just be a number that'll never change. It's a constant. And that number, that constant, tells you the y-intercept. It is the value of y when x equals 0. On the graph, it'll be where the line crosses the y-axis, which we call the y-intercept. It's where the graph intersects or intercepts with the y-axis. So that's what the constant term tells you. The other term tells you something as well. As again, that other term has an x in it, but there's also going to be a coefficient of x, a number in front, and that's what m represents. And m actually tells us the slope of the line. Whatever the number in front of x is, that tells us the slope of the line. So this is what this form tells us. And again, you have to remember, in order to get the slope and y-intercept from a line, you have to have it in slope-intercept form, which is y equals mx plus b. That means you got to have y by itself on one side, everything else on the other. Normally, you'll have two terms on the other side, a term that has x and a term that doesn't. The term that has x tells you the slope. The number in front of x tells you the slope of that line. B is the y-intercept. The constant term is the y-intercept. It's where the graph crosses the y-axis. So, an equation is written in the form y equals mx plus b is said to be in slope-intercept form. The number in front of x, referred to as m, represents the slope of the line, and the constant term b represents the y-intercept. So, for these equations, it says determine the slope and y-intercept for the following. Each one of them is in slope-intercept form because y is by itself. You've got y by itself on one side, On the other side, in most cases, you have two terms. Not always. That last example, y equals 7, only has one term. So we'll talk about what that means. But the first two have two terms, a term that has the x and a term that doesn't. The term that doesn't is the constant, and that tells you the y-intercept. So for this first equation, the constant term is positive 3. That will be our y-intercept. It's where the graph crosses the y-axis. It's where x is 0. So the y-intercept for that line will be the point 0, comma 3. And the slope is the number in front of x, which in this case is 2. And when we talk about slope, we mentioned this last class that slope is known as rise over run. Okay? So we normally, or we can, talk about slope in terms of a fraction. And that number 2 can be written over 1, and it doesn't change its value, but now it's in the form of slope, which remember is the change in y over the change in x, or the rise over the run. So for the next example, that equation is in slope-intercept form because you have y by itself on one side. On the other side, you have two terms. The number in front of x tells you the slope. That's 3 over 2. And the constant tells you the y-intercept, which is 12, or the point 0, comma 12. The y-intercept is where the graph crosses the y-axis. It's where x is 0. To get to a point on the y-axis, you don't go left or right. You just go up or down. Now, this next equation technically is in slope-intercept form because you have y by itself. The difference is that on the other side, there's only one term. But this would be the same as y equals 0x plus 7. 0 times x is still 0, which means that that term technically doesn't exist. But when you write it like this, then you can see that the slope is 0, or 0 over 1, and the y-intercept is plus 7, or the point 0, comma 7. So same thing with these next ones. The first one is in slope-intercept form. You've got y by itself on one side, the other two terms on the other side. The number in front of x tells you the slope, which in this case would be 2, or 2 over 1. The constant term is the y-intercept. That's positive 17, or the point 0, comma 17. The second one is in slope-intercept form. You do have y by itself, only now it's on the right side. It doesn't change the fact that you've got y by itself on one side. And on the other side, you've got two terms. The term that has the x tells you the slope. The number in front of x tells you the slope. The slope is 5, or 5 over 1. And the y-intercept is a constant term. It doesn't matter that the two terms are switched around. The term that doesn't have the x is the 8. A constant of 8 gives you the y-intercept of 8, and that's where x equals 0. Okay, the last one, again, is in slope-intercept form. You have y by itself on one side. On the other side, there are two terms. The number in front of x tells you the slope. It's negative 3, or negative 3 over 1. And the constant is negative 7. That's our y-intercept. And the y-intercept is on the y-axis. It's where x equals 0. So the point 0, comma negative 7 is the y-intercept. So let's see how we can now use this to graph a line. Instead of using a table of values, like I said, this gives us another way to graph lines. So it says you start with plotting the y-intercept and then use the slope to plot a series of points on the line. Plot at least 4 points before drawing your line. So let's see how this works. The first one, that line is in slope-intercept form because you have y by itself on one side, everything else on the other. Okay, so that line has a slope of 3, or 3 over 1. Remember, slope is rise over run. And the constant term is -1, so our y-intercept is at 0, comma, -1. To graph this line, we start with the y-intercept. The point 0, comma, -1 is right there. It's the y-intercept. It's where the graph crosses the y-axis. And then we will apply our slope. Our slope is 3, or 3 over 1. And again, slope is rise over run. So from the y-intercept, we're going to rise 3, which means we're going to go up 3. And we're also going to run 1, which means go to the right 1. There's another point on that line. A line is defined by its slope. If it's a line, that means it goes forever in the same direction, up, down, left, right, following that same line, that same angle, if you want, that same path. You don't have a straight line unless the slope is constant. From any 2 points on the line, the slope will be the same. The slope tells you what angle the line is going at. And so once you know what the slope is, it doesn't matter where you are on that line, the slope will be the same. So from the last point that we did, we can do another rise of 3 and run of 1. So up 3 more and run 1 more. There's a second point, actually a third point on that line. However, we can also say that the slope could also be written as -3 over -1, because if you divide -3 by -1, you still get 3. But writing it like this means you have a rise of -3 and a run of -1, which means you're going to go down 3. A rise of -3 means you go down 3, and a run of -1 means you go 1 to the left. And that point lines up with the other 3 points that we had. So we know that we've done things correctly. All those points line up. So now we can draw a line going through them all. With arrows on the end always, and there's that line. Now, if you have a graphing calculator, you can put this into your graphing calculator and make sure that it looks like the line that we drew. So we'll do that in a second here. So here's how that works in the graphing calculator. Up at the top here, top left button is y equals. This is what we choose if we're going to graph an equation in our calculator. So I have an equation in there already from something before. I'm going to clear that out. And in y1, I'm going to type in y equals 3x minus 1. So this says y1 equals, because you can graph more than one equation at a time. I think you can graph up to 10 different equations at a time. So this y1 equals, that's our y equals part from the equation. So all we have to do is type in 3x, take away 1. So I type in a 3, and then just at the top here below the mode key, you see a key that says x, comma t, comma theta, comma n. That's our variable key, and it's always x in our calculator. So I hit that button to get the x. And then I'm going to put a -1 in. And you have to hit enter after to activate that equation. So there, that equation is in the calculator. Now, we want our windows. You see beside the y equals key is our window button. And our windows tell us what our minimum value of x is that we see on our graph, our maximum value of x, and our minimum and maximum values of y. So if I go to window right now, mine have some crazy numbers in there. An x minimum of -10, an x max of +120. That's way too big. Ideally, we want them all to be between -10 and +10, the x and the y. So instead of going in and typing in those values, if I go zoom, the zoom key is to the right of the window key, and then number 6 in this list is zoom standard. That sets the windows between -10 and +10 on both axes. So I'll hit the number 6, it resets my windows, sets them to between -10 and +10 on both axes, and that's what the line looks like, which looks very similar to what we graphed. It's not exactly the same, just because of the size of the graph, but if we look and see that this graph does cross the y-axis at -1, which is what we got. Okay, so it looks very similar to what we graphed. So let's look at the next one then. Y equals 1/2 x. That is in slope-intercept form because you've got y by itself on one side. Now on the other side, there's only one term, 1/2 x. Remember, the number in front of the x tells us what, Liam? Put your phone away. It tells us the slope. The constant term tells you the y-intercept. Now, we don't have a constant term here, but we can put a +0 on the end. That doesn't change anything. That's actually our constant term, +0. Our slope is 1/2. Our constant term is 0, which tells us the y-intercept. And remember, the y-intercept is always where x is 0. And in this case, y equals 0. This graph goes through the point 0, 0. Not only is that the y-intercept, in this case, it's actually the x-intercept as well. When a graph goes through the origin, which is the point 0, 0, that's both the x and the y-intercept. So that's our starting point, our y-intercept. And now we will apply our slope. Our slope is 1/2. Remember, slope is rise over run. So you're going to rise 1, which means goes up 1, and run 2, which means to the right 2. We can do that again. Rise 1, run 2. We can do that again. Rise 1, run 2. But this could be written also as -1 over -2. -1 divided by -2, and negative divided by negative is still a positive. That's still equal to +1/2. But now we would rise -1, which means we go down 1, and run -2, which is to the left 2. Down 1, left 2. Down 1, left 2. Liam, I told you to put that away. So put it away. Thank you. All these points line up. So we can draw our line. So there's the line, the graph of y equals 1/2 x. Okay, looking at the next one. That equation is in slope-intercept form. You've got y by itself on one side, everything else on the other. Wayne, what's the slope? Jackie, what's the slope? Well, we're going to write it in this space right here. You tell me what to write. -2/5. Now, when a fraction is negative, it means either the top or the bottom is negative. So we can say -2 over +5, or we can say +2 over -5. Whenever a fraction is negative, it means either the top or the bottom is negative. They both can't be negative because a negative divided by a negative is a positive. Yes? Nope. What's the y-intercept here? What's the y-intercept, Princess? Huh? 0, 5. And that's where we start. The y-intercept is our starting point, and then we apply the slope from there. So we first had slope written as -2 over +5, which means you're going to run -2, you're going to go down 2 and run 5 to the right. 1, 2, 3, 4, 5. So there's that point. Now we don't really have room to go another 5 to the right. I mean, we can go 2 more down, but 5 to the right, we've run out of graph to do that. We can estimate where that is, but I think it'll be easier to try and estimate where a rise of +2 and a run of -5 takes us, because that's the same. From their y-intercept, we can rise +2, so we are going to have to kind of guess where that is, and then run -5 takes us over here. All those points line up, those 3 points, so we can draw our line through them. And we've put arrows on the end to show that it goes in those directions forever. Notice that the first 2 slopes were positive slopes, +3, +1/2. And so they rose as you went left to right. The last slope, though, is negative, and that's why it falls as you go left to right. All right, looking at this next one. That is in slope-intercept form because you have positive y by itself on one side, everything else on the other. So Keen, what's the slope of this line? If I wanted to write it as rise over run, what would it look like? You could write 2 over -1, or you could write -2 over +1. They are the same. They're both equal to -2. Remember, when a fraction is negative, either the top or the bottom is negative. Shiloh, what's the y-intercept? 0, +1. You want to bet a pop on that? Is she right, Kira? No. The constant term is +4, so the y-intercept is at 0, 4. Why were you doing that? Smarten up. Yeah, don't do it again. Okay, so we want to graph this. Where do we start, Danny? We start at the y-intercept, which is at 0, 4. Always start with the y-intercept. And now we can do either slopes, meaning we can go a rise of -2 and a run of 1, which means you go down 2. If you're going to rise -2, you're going down 2, but running +1 takes us there. We can rise -2 and run 1 again. We can rise -2 and run 1 again until we run out of room. All those points show a rise of -2 and a run of +1. Or we could rise +2 and run -1. We have room to do that on there. Rise +2, which means go up 2, run -1, which goes 1 to the left. All those points line up. So we can draw a line going through them. And there it is. This line has a negative slope, -2, which is why, as you go left to right, the line is falling. Okay, try that next one on your own. All done, Beckham? What's the slope, Beckham? Except there's a negative sign in front. So how would you write the slope of this one? Well, then you're saying they're both negative, and that's not right either. You can either write this as negative 1 over positive 3 or positive 1 over negative 3. Alicia, what's the y-intercept? Is that right, Riley? Okay, so how do we graph this? Where do we start if we want to graph this, Taylor? Negative y? Because I asked you, that's why. Where do we start? Negative 1 on the y-axis, on the y-line. Some really smart people call it the y-line. The rest of it just call it the y-axis. Now what, Lena? Now what? Right what? We go down 1 and to the right, how many? 3. Sure. We'll play your little game. If you say that the rise is negative 1, then the run has to be positive 3. So we'll go down 1 and to the right 3. We'll go down 1 and to the right 3. Don't have room to do any more points following that pattern, but we could do the opposite. We could rise 1, which means goes up 1, and run negative 3 would be to the left 3. All those points line up. So we can graph. And we always put arrows on the ends of our lines to show that that pattern is continuing forever. And again, this slope is negative 1/3. And because of that, the line falls as you go left to right. So this next one, what would you say the slope of that is, Kate? But that equals 0. And if this was 0, you wouldn't have an x term because 0x is 0. Riley? 1 over 1. That line has a slope of 1. There's no number in front of the x, but there is a 1x there. So yes, you can write it as positive 1 over positive 1, or also negative 1 over negative 1. Negative 1 divided by negative 1 is 1. Brooklyn, what's the y-intercept? 0, 5. And if we're going to graph it, that's what we start with, our y-intercept. 0, 5 up there. And we can rise 1 and run 1, which means goes up 1 and to the right 1. And we kind of run out of room to do any more with that pattern. But we have room to rise negative 1 and run negative 1. Down 1, 1 to the left. Down 1, 1 to the left. This line has a positive slope. The slope is positive 1. And because of that, the line is rising as you go left to right. Okay? So So let's look at some special lines where either there is only y or there is only x. We've already talked a little bit about how you can do or graph lines that only have the y and not the x. Like this first one, there is no x term. We could say in this case that there are 0 x's. So we can write it like that. 0x take away 5. So now it's in slope-intercept form. The y-intercept is at -5. So that is the point 0, -5. And the slope, m, is 0 or 0 over 1, which means you're going to rise 0 and run 1. If you rise 0, you don't go up or down. But you're going to run 1, which means you're going to go 1 to the right. And you can keep doing that. Go 1 to the right. And technically, you can go 1 to the left as well and saying it's 0 over -1 because 0 divided by anything is still 0. You could also say this is 0 over -1, which means you're going to rise 0 and run -1, which means going 1 to the left. This is a horizontal line. It's parallel to the x-axis, or as some really smart people say, the x-line. So that's one way to graph that line. Think of it in terms of slope of 0, a y-intercept of -5. But here's another way. The equation tells us that y always equals -5. And so that means that it doesn't matter what x is, the y value always stays -5. When x is 0, y is -5. When x is -3, doesn't matter, y still is -5. When x is +2 or +8 or +10 or +100, it doesn't matter. Y is always -5. So we can graph it that way. If we look at the next example, y minus 6 equals 0, so this one's a little different because you don't have the y variable by itself, but we can get it by itself by simply adding 6 to both sides. If you add 6 to both sides, now the equation is written as y equals 6. So again, it doesn't matter what x is, it can change, but y will always be +6. So when x is 0, doesn't matter, y is 6. When x is 2, doesn't matter, y is 6, yes? +6 because to get y by itself, we had to add the 6 to both sides to get the y by itself. We had to add 6 to both sides. Okay, so when x is -2, y is 6. When x is -4, y is 6. When x is +6, y is 6. The equation says that y always equals 6. So x can change, and it will, but y won't. So this is the line y equals 6. Again, it's parallel to the x-axis. So, question C below says x equals 3. You cannot put this in y equals mx plus b because there is no y in the equation. But that's okay. We'll just follow the same pattern that we did above. This tells us that x is always 3. Y might change, but x won't. X always equals 3. So when y equals 0, x equals 3. When y equals 2, x still equals 3. When y equals -4, doesn't matter. X is always 3. The equation tells us that. X is always 3. No matter what y is, x never changes. This line is a vertical line. It's parallel to the y-axis. That's the graph of x equals 3. No matter what happens to the y value, it will never change the value of x. It'll always be 3. So to know what x equals, you have to get x by itself. And so for question D, we need to do that step. We need to get x by itself by subtracting 4 from both sides. And this gives us the equation x equals -4, because on the right, 0 take away 4 is -4. And so this one tells us that no matter what y is, x will always stay -4. When y is 0, x is -4. When y is 2, x is -4. When y is -3, x is -4. This is a vertical line. Okay? That's the graph of x equals -4. All right. So remember that yesterday's assignment, graphing using a table of values, was due for marks. A bunch of you handed in already, and it's been marked. If you weren't here yesterday, you need to come and get yesterday's assignment. That was due for marks. And today's assignment, I will put the solutions on Google Classroom so you can check your answers. Remember, tomorrow we have a quiz.